প্ৰিয় শিক্ষাৰ্থীসকল, কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক দৃশ্য শ্ৰাব্য অনুষ্ঠানটিলৈ আপোনালোকক স্বাগতম জনাইছো। স্বয়ং প্ৰভা DTH চেনেল 20ৰ যোগেদি শিক্ষাৰ্থীসকলৰ অধ্যয়ন কাৰ্য অধিক মনোগ্ৰাহী আৰু ফলপ্ৰসূ হোৱালৈ লক্ষ্য ৰাখি বিভিন্ন বিষয় সামৰি আমাৰ এই বিদ্যায়তনিক অনুষ্ঠানটি সজোৱা হৈছে। আহকচোন প্ৰিয় দৰ্শকসকল, আমাৰ আজিৰ খণ্ডটিৰ মাজলৈ আগবাঢ়ো।
Dear learners, today I will discuss a unit that is Rules of Inference and unit number 7. In this unit, we will discuss only two basic points. First one is Rules of Inference and the second one is some solved examples of Rules of Inference. Now, this unit not only introduces to you the rules of inference but also the uses of the rules in case of formal proof of validity. It also provides us to go through some solved examples of the rules of inference in order to know how the rules of inference are applied to test the validity of arguments. Now, dear learners, you will see that what is rules of inference? In the preceding chapter, you have already come to know the formal proof of validity, which discusses the concepts like strategy for deduction. Rules of inference, rules of replacement, differences between rules of inference and the rules of replacement, test of formal proof, general suggestion for formal deduction, etc. Therefore, this unit emphasizes only on the application of the rules of inference. Now, dear learners, you will see there are 9 rules of inference. These rules are considered self-evident and are therefore valid without any proof. On the basis of these rules, we can determine the test of validity or invalidity of arguments. As we can derive a conclusion on the basis of self-evident rules, so the method of deriving a conclusion from the rules is called deductive method. Now, dear learners, you will see what are the rules of inference. You see, dear learners, first one is modus ponens, that is P implies Q, P therefore Q. This is the rules of modus ponens. So what it means? This rule means affirmation of the antecedent and on that basis consequent is affirmed. We can take an example of valid argument by applying these rules. Now, dear learners, you see, we can take an example. You see, dear learners, if Madhu is intelligent, he will be able to pass in the examination, and Madhu is intelligent, therefore he will be able to pass in the examination. And this argument can be symbolized as valid argument form of the rule of modus ponens. So you see, dear learners, how can we symbolize this type of argument? You see, we can symbolize this example. So in this way, P implies Q. P implies Q means if Madhu is intelligent, then he will be able to pass in the examination. And you see, P means Madhu is intelligent and therefore Q indicates that he will be able to pass in the examination. Now, dear learners, you see, there are also other valid argument forms of modus ponens. Now, dear learners, you will see there are also other valid argument forms of modus ponens. They are negation P implies negation Q, negation P, therefore negation Q. You see the second rules of inference, that is modus tollens. Now, dear learners, you see in the blackboard, P implies Q, negation Q, therefore negation P. So you dear learners, you see, this argument means the denial of the consequent, and on that basis the antecedent is denied. Means P implies Q, negation Q, therefore negation P. So dear learners, we can take an example of valid argument form by applying this rule, and the argument is, you see, if he wins in the maths, he will give us a party. He will not give us a party, therefore he does not win the maths. So this is the example of modus tollens. But how can we symbolize this type of argument, dear learners? You see that the symbolic form of this argument is P implies Q, P implies Q, negation Q, therefore negation P. This is the symbolic form of modus tollens. So this symbolic form is considered valid argument form of modus tollens. Now, dear learners, you see, the third rule of inference, rules of inference is disjunctive syllogism. So you see, dear learners, P val Q, negation P, therefore Q. So this is the rule of disjunctive syllogism. This argument holds that if one of the options or disjuncts is denied in the minor premise, the other option or disjunct is accepted in the conclusion. So we can take a real example of disjunctive syllogism. Dear learners, you see in the blackboard, either he will win or defeat in the maths, he will not win in the maths. Therefore, he will defeat in the maths. So this is the real example of disjunctive syllogism. But how can we symbolize this real example? You see, dear learners, how can we symbolize? So P val Q means either he will win or defeat in the maths. Either he will win or defeat in the maths. If we take P and if we take Q here, then it means P val Q. P means he will win or Q means defeat in the maths. Then you see, this means he will not win in the maths, which means negation P. So, and the last one, that is conclusion, he will defeat in the maths, means Q. So this is, in this way we can symbolize the example P val Q, negation P, therefore negation Q. Now, dear learners, you see the fifth rule of inference is, that is hypothetical syllogism. So how can we write this type of rule of hypothetical syllogism? P implies Q, Q implies R, therefore P implies R. Dear learners, you see, this rule means that both the premises are conditional statements and they have one common statement. The common statement is known as antecedent in one premise, and the other is consequent in another premise. We can take real example. Now we can take, dear learners, real example of hypothetical syllogism in order to better understand its logical form. Now you see, dear learners, we can take a real example of hypothetical syllogism. If Madhu is intelligent, he will be able to pass in the examination. If he passes in the examination, he will be able to get a job. Therefore, if Madhu is intelligent, then he will be able to get a job. So this real example we can symbolize, dear learners. So you see, how can we symbolize this real example of hypothetical syllogism? P implies Q, Q implies R, therefore P implies R. So this is a valid form of hypothetical syllogism, dear learners. You see, the next rule of inference, that is conjunction, that is, you see, dear learners, P and Q, therefore P and Q. You see, dear learners, P, Q, and therefore P dot Q. This rule means that the first two premises are joined together by the word and. Next one, you see, simplification rules. So P dot Q, therefore only P. So this is the rule of simplification. This rule states that if the two premises are joined by the word and or by the symbol dot, the first variable or conjunct can be inferred as the conclusion. P dot Q, therefore P. So this is the rule of simplification. Now, dear learners, you see the seventh rule, that is addition. So P, so you see P, therefore P fell Q. So this rule is known as addition. So this rule means that we can add variable or variables to the premises by the symbol fell. Now, the next rule is absorption. P implies Q, therefore P implies bracket begin P dot Q bracket close. So according to this rule, consequent carries antecedent, consequent carries antecedent in the conclusion. So this is the rule of absorption, dear learners. Now you see constructive dilemma. This is another rule of rules of inference. How can we write, dear learners? You see, P implies Q, R implies S, P val R, therefore Q val S. So what this rule means, that this rule indicates that, or this rule states that there are two conditional propositions and a major premise possesses two different antecedents. You see, major premise indicates, or major premise possesses two different antecedents. Here it is P or here it is R. So you see, therefore both denotes different consequent. We can take a concrete example to understand. If a man is honest, he must be respected. And if he is a social worker, he must get reward. So a man is either an honest man or a social worker. Therefore, the conclusion is either he must be respected or he must get reward. So how can we symbolize this type of concrete example, dear learners? You see, P implies Q dot R implies S and P val R, therefore Q val S. So this is a valid form of constructive dilemma, dear learners. Now you see another rule of rules of inference is, that is destructive dilemma. Dear learners, you see, so again P implies Q dot R implies S dot negation Q val negation S. Therefore, negation P eval negation R. So that is destructive dilemma. In the previous one, you have already the idea of constructive dilemma. Here the next one, the opposite one, that is destructive dilemma. Now dear learners, you take a concrete example, then you will be able to know. So we can take a concrete example in order to understand its logical form. If a man is honest, he must be respected, and if he is a social worker, he must get reward. A man is either not respected or does not get reward. Therefore, the conclusion is either he is not honest or not a social worker. So this is all about a concrete example of destructive dilemma, dear learners. So now the next step is, how can we symbolize this type of concrete example? Now dear learners, you see how can we symbolize. So in this way we can symbolize. P implies Q dot R implies S dot negation Q hell negation S. Therefore, negation P val negation R. So this is a valid form of destructive dilemma. So dear learners, this is all about the rules of inference. So how can we symbolize the concrete example? The idea is given to you in the previous slide. Now you see, how can we determine the validity of arguments applying the rules of inference? So you see, dear learners, therefore it is given the solved examples of rules of inference. Now you see, dear learners, there are some solved examples of formal proof of validity given in this section in order to understand how the rules of inference are applied to test the validity of arguments. Now dear learners, you see, this is an example. So we have to apply the rules in order to find out the conclusion. Now dear learners, you see, first step is P implies Q, second one is Q implies S, third one is P, and the conclusion is S. Now you see, how can we find out the conclusion S applying the rules of inference? Now dear learners, you see, first and second by hypothetical syllogism. First and second, if we use the rules of hypothetical syllogism, then we find out the conclusion, that is S. So you see, first we have to apply first and second by hypothetical syllogism. First and second we apply our hypothetical syllogism. Then we find P implies S. Then fourth and third, this is fourth and third, we have to apply by modus ponens. Then we find the conclusion S. So in this way we have to find out the conclusion, or we can test the validity of arguments by applying the rules of inference. So this is a solved example of rules of inference, dear learners. Now you see another one. That is, first one is P val Q implies R. Second one is S val P. Third step is negation S and conclusion R. So here also we have to see what are the rules we have to apply here in order to deduce the conclusion R. So dear learners, you see, so in fourth step we find P. How can we find P? We have to apply second and third by disjunctive syllogism. Here you see second and third we have to apply disjunctive syllogism. Then we have to find P. Next you see how can we find P val Q. Here also you see 4 addition. This is for P val Q. So this is the we here apply addition rules. Now you see the next step are the conclusion are how can we find out, how can we deduce 1 and 5 modus ponens. 1 that is 1 and another 5, so that is R. We apply here modus ponens rules 1 and 5, then we find out the conclusion R. So this is another solved examples of rules of inference, dear learners. So dear learners, you see here P implies Q, R implies S, P val R, fourth step Q val S implies T, and the conclusion T. Now you see how can we find out or how can you deduce the conclusion T out of these 4 steps. Now you see 1 and 2, that is constructive dilemma. So we have to apply this. Then we have find Q val S. Next one 4 and 5 we apply modus ponens rules, then we find out the conclusion T. So this is another example of rules of inference, dear learners. Now you see, first we have to another way of deducing conclusion out of the premises, means there are some real examples given to you. You have to symbolize the argument. After that you have to prove how can we deduce the conclusion out of the premises. So you see out of the premises. So you see there is a real example given to you, that is if rain comes in time, farmers will be happy. So how can we symbolize? That is R or F. R means rain or F means farmer here. So R implies F. We can symbolize this example. If rain comes in time, farmers will be happy. So we can symbolize R implies F. Next one, if farmers are happy, there will be good crops. How can we symbolize? Again, farmers F, and that is C. So F implies C. The rain comes in time. So we can symbolize here giving R. Rains come in time. Then the conclusion will be there will be good crops. So that it would be good crops. That is conclusion C. So how can we deduce, dear learners, the conclusion C out of these 3 steps? Now, dear learners, you see, we apply here 1 to hypothetical syllogism. By applying 1 to hypothetical syllogism, we find R implies C. Now you see, how can we deduce the conclusion then C? We apply 4 and 3 rules, modus ponens rules here. 4 and 3 means that is we find out the conclusion C applying modus ponens rules in 4 and 3 steps. So this is the solved example of rules of inference, dear learners. So this is all about the rules of inference. How can we apply the rules of inference in order to deduce the conclusion? Dear learners, now you see what are the basic points in this unit rules of inference. Now dear learners, you see in the blackboard, rules of inference are considered self-evident and are therefore valid without any proof. On the basis of these rules, we can determine or test the validity or invalidity of arguments. That is why these rules are known as deductive method. Second one, modus ponens means what? Affirmation of the antecedent, and on that basis consequent is affirmed. Modus tollens means the denial of the consequent, and on that basis the antecedent is denied. And another basic point is this argument holds that if one of the options or disjuncts is denied in the minor premise, the other option or disjunct is accepted in the conclusion. Now you see, dear learners, another basic point, that is hypothetical syllogism means that both the premises are conditional statements and they have one common statement. The common statement is known as antecedent in one premise and other is consequent in another premise. Dear learners, this one is disjunctive syllogism. This one is disjunctive syllogism. So dear learners, so this is all about the basic points of rules of inference, dear learners. Now dear learners, you see what are the books you have to consult or you have to read in order to know the unit in a very comprehensive way. So dear learners, you can take the book that is Sonda Chakraborty, Logic, Informal, Symbolic and Inductive. So this book you can take. Another one, Irving Copy, that is book is Symbolic Logic, and Cohen Copy, that is Introduction to Logic, and R.C. Munshi, Handbook of Logic, and Shyam Kishore Singh book, Modern Logic. And you can also take another very important book, that is Krishna Jain, A Textbook of Logic. I think, dear learners, you have understood by going through this unit, and for understanding on, in order to know more, you have to consult with this book. What are the books I have already given to you? So dear learners, thank you.
ইমান সময় আমি স্বয়ং প্ৰভা DTH চেনেল 20 যোগে সম্প্ৰচাৰিত কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক অনুষ্ঠানটিৰ আজিৰ খণ্ডটি উপভোগ কৰিলো। এই বিদ্যায়তনিক অনুষ্ঠানটিৰ জৰিয়তে শিক্ষাৰ্থীসকল নিশ্চয়কৈ ভালেখিনি উপকৃত হৈছে। পুনৰ আন এটি বিষয় লৈ আমি আপোনালোকৰ মাজলৈ আহিম। নমস্কাৰ।